Welcome to a fascinating journey through the fundamental properties of matter and energy transformation, focusing on the science of heat. Created by LARK Labs, this presentation will delve into the laws that govern our physical world, starting with the intriguing characteristics of liquids. Matter is the substance that occupies space and has mass. It is composed of atoms, the building blocks of all substances, and can exist in various states such as solid, liquid, or gas. As heat energy increases or decreases, matter can change from one state to another, making it essential to comprehend how the physical world operates around us. Solids have a definite shape and volume, with molecules tightly packed together. They exert pressure downward due to strong intermolecular forces and little molecular movement. This structure is evident in ice, where molecules are locked in a rigid crystalline form, showcasing the unique properties of solids. Liquids have a definite volume, but take the shape of their container. Their molecules can slide past each other, exerting pressure in all directions. This characteristic explains why water always seeks its own level in connected containers, a principle used in plumbing and hydraulic systems. Gases have no definite shape or volume, with molecules widely spaced and moving freely. They exert pressure equally in all directions, allowing them to fill any container completely. This property is crucial in HVAC systems, where gases must flow through ducts and pipes efficiently. Mass, weight, and density are important physical properties of matter. Mass responds to gravitational attraction, weight varies with gravitational pull, and density relates to the mass-to-volume relationship of a substance. Understanding these properties helps us see how different substances behave and interact in various environmental conditions. Specific gravity is the density of a substance compared to the density of water. It provides a way to measure how much heavier or lighter a substance is compared to water. This concept is crucial in industries where density plays a significant role, such as brewing and refrigeration. This table provides a quick reference for the densities and specific gravities of common materials in HVAC systems. Metals like copper and brass have much higher specific gravities than liquids and gases, aiding in selecting appropriate materials for different applications and calculating fluid behaviors in heating and cooling systems. Specific volume is the volume occupied by 1 pound of a gas, expressed in cubic feet. It is the inverse of density, highlighting the relationship between the two. This concept is particularly important when working with refrigerants and calculating system requirements in HVAC applications. Gas laws describe how gases behave under different conditions of temperature, pressure, and volume. Boyle's law, Charles's law, the general law of perfect gas, and Dalton's law form the foundation for understanding refrigeration cycles, air conditioning systems, and pressure-temperature relationships in HVAC technology. Boyle's law states that for a given mass of gas at constant temperature, the absolute pressure varies inversely with the volume. This principle is applied in compressors, gas cylinder storage, and air brakes in vehicles, helping troubleshoot HVAC systems by understanding pressure changes. This illustration shows how absolute pressure in a cylinder doubles when the volume is reduced by half. This inverse relationship is the principle behind many compression processes in refrigeration and air conditioning systems, aiding in the design and operation of compressors. Charles's law states that for a given mass of gas at constant pressure, the volume varies directly with the absolute temperature. This law is crucial for understanding how heating systems and evaporators work in HVAC technology, emphasizing the importance of using absolute temperature scales. This illustration demonstrates how a gas expands when heated while maintaining constant pressure. Real-world examples include hot air balloons rising and car tires losing pressure in cold weather, showcasing the direct proportionality between volume increase and absolute temperature. The general law of perfect gas combines Boyle's and Charles's laws to relate pressure, volume, and temperature changes for a fixed mass of gas. This law is essential for designing compression systems, predicting system behavior, and ensuring efficient operation in HVAC systems. Dalton's law states that the total pressure of a mixture of gases equals the sum of the partial pressures of each gas. This principle is vital in refrigerant mixtures and humidity calculations, helping understand how each gas contributes to the overall pressure in a system. Energy is the capacity to do work and is the driving force behind all HVAC/R systems. It can be conserved, transformed, and measured, playing a crucial role in converting electrical energy into mechanical energy, facilitating the transfer of thermal energy from one location to another. Heat always flows from higher to lower temperature regions, illustrating the second law of thermodynamics. This principle is foundational in refrigeration and air conditioning, where heat is removed from a space and transferred elsewhere, ensuring efficient temperature control. Work is the application of force through a distance, measured in foot-pounds. In HVAC systems, work is performed when compressors move refrigerant or fans circulate air, highlighting the importance of calculating the amount of work needed for efficient system operation. Power is the rate at which work is done, measured in watts or kilowatts. Understanding power ratings is essential for selecting motors, compressors, and other components in HVAC/R systems, determining how quickly a device can perform work and convert energy. Horsepower is a historical concept developed by James Watt to express the power of horses. In HVAC/R systems, it helps ensure proper sizing of compressors and motors, with higher horsepower allowing more work to be done in less time, requiring more energy input.